Here are the solutions to pages 380, 381, 410, and 18. So for number 4, we definitely want to set up the integral with respect to y. So remember, we're changing the axis we're looking at here. So in this case, it's going to be the area is going to equal the integral from 0 to 1, because we're going along the y-axis, and then it's your rightmost curve minus your leftmost curve. So here we have carefully written out 12y squared minus 12y cubed, that's our rightmost curve, minus the quantity of 2y squared minus 2y dy. And then you want to carefully distribute, combine your like terms. So end up getting a negative 12y cubed. 12y squared minus 2y squared gives us 10y squared, then we'll get a plus 2y. Take the antiderivative of that. You could show this, or you could go straight to this step right here. And then carefully substituting everything in, we should get 4/3 square units. So remember, with respect to x, it's our integral as x goes from this value to that value of our top curve minus our bottom curve. With respect to y, it's the integral as y goes from whatever value to whatever value along the y-axis, and it's our rightmost curve minus our leftmost curve. Here we didn't have to switch anything. Number 10 we do. Now for number 10, it's actually best to use with respect to x because it's solved for y in terms of x. And it's a lot easier to go along the x-axis here. So we have 3 sections we need to look at. So yes, this one was pretty long as far as the work involved. But our first integral goes from x equals -2 to x equals -1. Our line is the top curve. Our parabola is our bottom curve. So we have -x plus 2 minus the quantity 4 minus x squared. Again, as x goes from -2 to -1. Don't forget the dx. Plus the next set, our curve switch. We're going from -1 to 2. Our top curve is the parabola, 4 minus x squared, minus the quantity -x plus 2 dx. And our third curve, we're back to the line being the top curve and our parabola being the lower curve. So we're the integral from 2 to 3, -x plus 2, minus the quantity 4 minus x squared. The rest is just combining like terms, taking the antiderivative. So you could pause the video to look over each step. Now this is very important. Make sure your signs are correct. Other than what I have out in front, I still like to put it in the quantities. That way when, in parentheses, that way when we go back to look, I know that this is everything that deals with the second integral and everything that deals with the third. What you do after this is up to you. I like to combine all the integer values and kind of rearrange my fractions to get common denominators together. So right here, I took a positive 8/3 minus 1/3, gave me the 7/3 minus the 1/2, and then this becomes a 2 minus a 2, so that's gone. Next over here, I had a negative 8/3 minus a 1/3, which is negative 9/3, so that's -3. Kept the minus 1/2. Then we get a 6 plus a 2, which is 8. Over here, I just put the negative 8/3 first and the minus 9/2. We get 9 minus 6, which is 3. Then we get 3 minus the negative 6, which is plus 9. Still rearrange some terms here. So this gives me 7/3 minus 8/3 is negative 1/3. Negative 1/2 minus a 1/2 give me a -1. I just move my negative 9/2 here, plus my 5, plus my 9. So that's going to give me a 13. I got common denominators over here. And we end up with 49.6 square units. Right, and number 18 was another good one with respect to y. We weren't given the graph, which means we have to graph it. But first we should find the points of intersection. So I said, now again, we want this with respect to y. But when we go to graph it, I'm just going to quickly solve for x because it's a lot quicker to graph when it's solved for y in terms of x rather. So my y values of my points of intersection are y equals -1 to y equals 2. Here's what the graph of that looks like. And then this is the area we're looking at. So again, I only need one integral. It's as y goes from -1, there's my first point of intersection, to y equals 2. My rightmost curve is my line, y plus 2 minus my parabola here, sideways parabola, so minus the y squared. Compared to the last problem, much simpler. Again, just careful with your signs and your fractions, but you should get either 9/2 or 4.5 square units. So please let me know if you have any questions over these.